are a chief architect at Huawei Cloud, and you've been building a CPU-based workloads for almost 20 plus years. But now we are on to GPUs, right? The serverless, we're exclusively talking about serverless here. So serverless might work for CPUs. It worked, AWS Lambda did a great job when they introduced that and bringing serverless into CPUs, where multiple users can share the infrastructure and they can deploy their workloads on demand. But when it comes to GPUs, it's a completely different mechanism. Could you explain why it is so different?
Okay. Yes. Yeah. Let's first define what is a serverless. Actually, serverless started to be popular maybe 10 years ago when the AWS released the Lambda. At that time, Lambda just serverless could be just we can think it just equal to the function as service. That's it have two major characters. The first one is on-demand serving. That means when this user request come in, serverless platform will start the instance to serve this request. And another character is that it will scale down to 0. That means when there's no request, the platform will terminate all the instance to release the resource. Based on these two characters, that's users service don't need to waste resource when it's idle, so that customer can just pay for the serving instead of pay for the idle. That's the major purpose of the serverless. Yeah, serverless heavily rely on the cold start for the user experience. For the CPU world, for the lightweight CPU work-based application, it's easy to achieve sub 1 second cold start. And even for the heavy CPU workload, it's also easy to optimize that to cold start in less than a few seconds. But for the GPU application, cold start latency could be more than 10 seconds, very easily to almost all the GPU workload will be almost more than 10 seconds and will go to tens of minutes. And this slow cold start block serverless in the GPU world.